Thank you very much for having me. This is a very interesting conversations that was going on right before I joined. But I think I heard enough to get the context and the whole I would say performance aspect seems to be a very prominent topic right now. And like I heard Mr. Chin saying earlier, one of the differentiated aspects of 5G, will be the enabling of real-time applications, and in that domain, high performance will be the name of the game, it seems, and this is what we're going to talk about today. We're going to talk about the underlying network aspects. We're going to talk about the application service delivery aspects, and we're going to talk about how this all comes together with analytics, automation, etc. So let's get started. So did you see my screen flip? Perfect, very good. So, well, one of the main places where we see, where operators are looking to realize some profitability gains with 5G, because like it was said earlier, 5G, is great, but everybody's looking for ways to make money with it because there's cost associated with it, etc. And of course, enterprise services seems to be a bright area where there's good ways to differentiate here, and that's where we think edge compute will be making a big difference. So whether it's with industrial, automotive, energy, or healthcare applications, for instance, these all share a common thing. They require pretty tight performance with things such as millisecond data processing, low latency, high throughput, but also, as we'll see, overall performance throughout the entire 7-layer stack and all the way to the application layer, where things like small degradations in performance can greatly affect the end user experience. Hence, the business opportunity for operators to differentiate with the best assured performance. Now, why is such performance needed at the edge for these types of services? Well, what we're showing here is, these minimum performance requirements must be maintained just for the service to be adequate. Never mind if you want it to be differentiated. So as you can see, some of these are pretty stringent, especially around maximum jitter, for instance, or maximum tolerable packet loss. And one can see that for these, providing microsecond accuracy will be paramount, not to say table stakes. Essentially, the basic thing for a 5G edge infrastructure to be sane is to have a high performance underlay network. Otherwise, it simply won't work. And the challenge in this case will be to provide microsecond accuracy for these types of measurements. Now, compared to 3G and 4G, the assurance of 5G adds multiple new dimensions. Firstly, the decentralized compute and mesh nature and connectivity means more physical paths and more locations to assure. So certainly a solution that requires scaling both geographically and throughout the entire application stack. Obviously, virtual service layers will add an abstraction topology on top of the physical topology that will need very tight monitoring, but also dynamic monitoring. And then third-party applications that are really hosted as part of an ecosystem, increase complexity and will call for things such as additional security. And then to make all this work together, there's going to be a huge need for automation to take the right decisions. But to take the right decisions will require very accurate data, like we're going to see. So beyond all these things, 5G edge compute will need dynamic assurance. The dynamic nature will be very important of it. But there's also a fixed nature to it. So As we can see in this diagram, at the bottom, the subtending network infrastructure will require an assurance underlay that is at fixed locations, that is continuously on, and highly precise, which in some case may also require things like hardware assist, and which sometimes may be the only way to achieve the microsecond accuracy of measurement that we were talking about. Now, on the other hand, at the top of this diagram, the service layer that is defining the applications to be delivered and the user experience, that's much more fluid, and it requires dynamic assurance, which can be changeable, movable, and follow the services, and sometimes not necessarily active 24/7, so really activated on and off on demand by the automation and orchestration layers. Now, of course, both of these aspects, the top one and the bottom one, will need to be correlated, along with things such as third-party infrastructure data as part of a single analytics engine, all of which will be required to derive actionable and automated insight. Now, of course, who says differentiation in 5G says network slicing, where each slice requires its own monitoring function, and whether it's to assure high capacity mobile broadband or low latency real-time services, or low bandwidth but high reliability massive IoT services, you know, all of these will need different types of SLAs for each of those types of services within each slices. And all of these will also require automation, whether it's to enable fast fault finding, whether it's to allow the scaling of these slices in an orchestrated manner, or whether it's to select alternative paths automatically in the case of a failure, or to, like I said earlier, to scale both not only the network, but also the compute resources dynamically in a closed loop fashion. Now, closed loop will be a term that you know, we're going to hear more and more in a 5G and multi-access edge compute environment, just because there will be so many of these things to manage at the same time that they will need to be automated in terms of self-optimization. And speaking of closed loop, here's the 5G slice assurance model as proposed by the TM Forum. And so what you can see there, starting at the bottom, making all of this possible, is the slice assurance function. So monitoring the slices individually and streaming the results in real time. So the streaming aspect will be very important. Again, just because all of this will need to feed an automated orchestration system. And so in this case, it will feed the slice SLA conformance function, all of which will go through you know, the orchestration function to automatically increase things such as resource allocation where needed, and leverage the slice assurance function once again to make sure that this cycle correctly addressed the situation. So really the idea here is, you know, a virtuous circle of continuous optimization in an automated fashion. Now, all this is great for 5G and the network layer, but let's talk a bit more about the edge cloud overlay and how such a compute tier compares to other tiers. So what we can see here is at the top that the public cloud is really optimized for mass access, but with relatively high typical latency. Obviously, you know, it's still good latency, but compared to the other cloud tiers, it's the one which can tolerate the highest latency. Then enterprise private cloud is optimized for CPU heavy workload type, but with lower latency. Whereas in third row, the edge cloud has a workload of type quote unquote immediate, but has a relatively high cost of compute but needs to operate within 1 millisecond. So what we realize when looking at this is that typical applications will not be confined necessarily within one compute tier, but will rather span multiple tiers. And therefore, the interconnectivity between all these tiers will require assurance in a mesh fashion across all these segments in order to deliver a quality of experience and the availability required for the end users. And the end user experience in the end is defined as, you know, the end user response time between the device, the user, and the actual application that may be running in the public cloud in a lot of cases, though in many cases this will be alleviated by running parts of the applications or the content in the edge cloud. But in the end, many cases, you know, the application and the end user experience will traverse all the tiers, from the vehicle, for instance, all the way to the public cloud and in a return path. And it's that longest, unfortunately, it's always the longest round trip response time that most of the time, you know, defines the end user experience. And hence the need to assure performance from end to end, but also to be able to identify the delay contribution of each of the tiers along the way in such a stack. So what we see emerging from this is that a common trust model will be required to assure both the subtending infrastructure and the application services being delivered on top, where both passive and active techniques will be used, for instance, on the left side of this picture to assure things such as links, paths, message buses, vSwitches, etc., from layer 2 to layer 4, while on the right side of this picture, passive and active techniques are also being used to assure all the way to layer 7 for things such as service containers, virtual machines, APIs, etc. And this common trust model needs to operate in a mesh fashion from operator to cloud, for instance, but also from cloud to cloud, from edge to cloud, from edge to edge, from thing to edge, etc., for all the various permutations, all of which should be feeding into, ideally, into a central analytics engine for correlation and the closed loop automation that we were talking about, which will enable the various orchestrators to optimize both the network and the compute environment in real time. Now, speaking of orchestration, what we can see is that in a closed loop automation scenario, the 3 different orchestration layers will need to feed from different types of KPIs, both from the infrastructure underlay and from the application service overlay. So for instance, in this case, RAN orchestration will be focusing on the subtending mesh network performance, but also will be checking app availability as a final sanity check for its optimization cycles. While in the middle tier there, edge orchestration will really be looking at a hybrid set of both infrastructure and application KPIs. So things such as edge to cloud performance and API gateway performance, for instance. And then finally, at the application service orchestration layer, it will focus on things such as the sanity of the message bus, DNS service, HTTP, and cache performance, for instance. Now, in reality, in the field, all of these things will really be compounded to an nth degree of magnitude and of complexity when facing like a real-life heterogeneous environment involving multiple operators that will be, for instance, RAN sharing or using alternate access providers in order to provide connectivity, along with potentially a combination of multiple edge platforms. And all of this going into the public multi-cloud on top of that. for instance. So it'll look really like this kind of picture. You know, making ultimately the need for a common trust model even more important. Because in the end, what we're going to see here is that, you know, you're going to have all of these public cloud providers that, you know, amongst other things, will be extending their tentacles into the service providers' multi-access edge compute locations in order to get closer to the end users. And at the same time, offering value-added, real-time, sensitive applications. Now, on the other hand, on the flip side, the way the enterprises will be leveraging this is that, you know, several operators are looking to do things such as leasing and hosting applications of enterprises in their mobile edge compute locations. And so what these operators and enterprises are going to need is, again, a common trust model where these two parties will be able to agree on a common SLA, not only for the underlying network, but also for the host of applications and the host of multiple third-party solutions that will be hosted as part of these distributed compute environment. So in conclusion, what we see is that, you know, the combination of both a high accuracy network performance and end user experience visibility and monitoring will be key to create these differentiated 5G experiences for the enterprises, but also ultimately for the end users throughout. So I think this, you know, concludes my presentation. Now off to the audience for any questions that you may have.
Patrick, I'd just like to say thank you. I think that was a terrific presentation, and I think some of your graphics are really wonderful in summing up the complexities of edge, and I particularly liked the 4 tiers of distributed computing. And we're still talking about OSI layers all this time later is kind of slightly amazing as well. Okay, I'll stop talking. We have some good questions here. So I'm going to start with Eduardo, and this actually comes back to a point you made early on, and it seems to me this is one of the trickiest areas, which is automation needs better data. Basically, if the data is not good enough, forget the automation. And Eduardo is just asking, you know, have we got any of these kinds of real big data smart platforms right now that we're talking about that we need? And have we really got those terrific algorithms? And I'd say also, have we got the data?
So as far as the data is concerned and providing that high accuracy data and the data throughout the stack, that is our job at Accedian. And you know, we've been doing that for years and specializing ourselves in providing the most accurate, the most up-to-date, and, you know, to feed that streaming data in real time. What we've actually started to see is our customers started to use this data as part of these closed loop automation cycles. I would say the collection, the storage, and the leveraging of this data is really only in its infancy. What we can see today is that a lot of this data is being kept for things such as historical purposes, forensics purposes, et cetera, et cetera. But to feed those in closed loop for self-optimization and self-optimization, self-automation and self-optimization is something that we've seen to date in you know, a handful of service providers worldwide that are doing it, again, especially for enterprises and for value-added SLAs. One of the things that we've started to see with these types of closed loop automation schemes is to offer a new grade of service, if you want, which dynamically scales itself. So an enterprise, for instance, instead of having to log on into an on-demand portal to increase its bandwidth, can now preset an automatic set of triggers that will self-scale the network or the compute in order to always provide the best end user experience.
Okay, so from Sandra Aboyle, she is asking if communication service providers are really prepared for this level of real-time and dynamic end-to-end performance management. She says because today there's very limited service level agreements offered on mobile services, and yet we're talking about this very, really high customer expectations with 5G. How to prioritize, where to begin. We are kind of going from jumping over a pole on the ground to the pole vault here, really, aren't we?
Yes, indeed. And I would say that the level of readiness is there on the enterprise services side, and it's been there on the wireline side for some time. The SLAs, if you want, that service providers have been offering to fixed line for things such as financials and so on and so forth, or real-time critical applications such as emergency response and so on and so forth. Those have been going on for some time. Now, moving this into the 5G world and into the multi-access edge compute world, that is really the area where several operators are starting to work and to really associate that with their 5G deployment in order to offer more than just another speed grade on a phone, but to really enable the next generation distributed enterprises to become a reality. And I would say that, unfortunately, the current situation with the pandemic has had two aspects. One of them has been to slow down the deployment, making site access more challenging. But on the other hand, the need has never been more acute for enterprises to have a distributed workforce, to have distributed performance, and yet being able to offer seamless end user performance for the end customer in the end, which is the one requiring such a high performance.
Yeah, I think it might turn out in the long run that the pause created by the horrible virus might actually be quite helpful, because it gave us time to think and reset a little about what we really need to be doing here.
Yes, indeed. But a lot to be done for sure.
Sorry?
But there's a lot to be done for sure.
Okay, we have some more questions for you, Patrick, but unfortunately, I have to move on. So if it's okay with you and with the questioners, we'll forward those to you to be answered offline. And in the meantime, Thank you very much. That was.
We'll be delighted to answer those questions. Thank you very much, Annie.
Thank you very much, Patrick.